This is my Quideo 2, and we're going to talk about the basic question first today. In the basic question, it gives you this chart talking about the cars that people buy and the probability that a person would buy this certain colored car. So the first question said, what's the probability that the vehicle chosen has any color other than these six? So you have to take into account, like, all of these are basically percentages. So you minus them all together, and you get 0.705, so about 70.5%. And then this is basically saying 100 minus 70.5%, but I put it in decimals just to make it easier on myself, and I got 0.295, which transfers over to 29.5%. And that's that remaining percent from the 100 that would be those other colors, other than those six shown. So the next question is, randomly chosen vehicle is either silver or white. So basically, what's the probability that that vehicle is going to be silver or white? So that or makes it an addition, and you add your silver and your white, so 0.176 plus 0.172. They're very close to each other. And you get 0.348, which transfers to 34.8%. So you would get about a 35% chance that you would choose a vehicle of either silver or white color, just if you randomly chose it. Next question is, when choosing two vehicles at random, what's the probability that both are silver or both are white? So saying that the both are silver or the both are white, you times them together, and so that's my both are silver and that's my both are white, and you add those together because it says or, so it's add, just like up here it was or and add. And I got 0.0606, which transfers to 6.06%. So a very, very small probability that those two vehicles at random would be silver or white. But yeah, that's your probability. Our advanced question. And this talks about, will taking antioxidants help prevent colon cancer? So it's kind of like a clinical trial or whatever on colon cancer and taking antioxidants helping prevent the colon cancer. So they chose people that were all evenly subject to get colon cancer, and they basically, their hypothesis was fruits and vegetables lower the rate of colon cancer, so they took the antioxidants that they found in fruits and vegetables, so vitamins A, C, and E, and put those into groups. So your four groups are daily beta carotene, daily vitamin C and E, all vitamins every day, and a daily placebo. So you do have that control group, and there were 864 people studied, and like I said, they were all evenly at risk of colon cancer. And after 4 years, they basically made the conclusion that there was no significant difference in colon cancer among the different groups. So yeah, that was based on their data. So it asked for their explanatory and response variable, and I said their explanatory variable was the antioxidants, the amounts, and what kind they were using. Since the amounts were kind of the same, it was more on like what kind of antioxidants they were given every single day, whether those ones prevented the risk of colon cancer. Then the next question asked for the design outline that I would do just to divide all of those people into 4 even groups, and how I would do that. And I just said that I would use a random number generator to assign the people to groups by 1, 2, 3, or 4. So these would be your groups, and these random numbers would be randomly assigned to these different groups. So they would have no idea what they were being given, keeping it that double blind that we talk about later. And I would make even groups of 216 people each. So you got the even amount of data and the even amount of people. Antioxidants given to each person. The next question was using table B, basically saying what are my first 5 subjects. So it asked about line 18 with here. So here's line 18, and it wants groups of 3, so the numbers are grouped in 3. So our first one is 731, next one is 903, next is 253, 304, and 470. So those would be those 5 that we would get randomly from line 18. And there is where I wrote it down, just in case you needed that. Alright, our next question was, what does double-blind mean in the context of this problem? Double-blind basically means that the doctors nor the patients knew what they were getting every day. So, like I said, it was randomly assigned, and since it was so randomly assigned, neither the doctors nor the patients knew. So the patients didn't know if they were getting a placebo or vitamins C and E or the daily carotene or what they were getting. It was kind of just a random assignment. And then the next was asking about lurking variables for why people that eat lots of fruits and vegetables have lower rates of colon cancer. And I said people that eat lots of fruits and vegetables are usually very active and very healthy. And also their diet could consist of more fiber. Both of these variables lead to a healthier intestinal system and a cleaner colon, basically saying that the colon is in a healthier condition and less likely to get cancer. Usually people that don't take care of their colon, don't have enough fiber in their diet, get colon cancer more often, but it is also a hereditary thing, so that really can't be prevented with fruits and vegetables. But those would be your lurking variables in this particular study. Next up is our AP question. And this question was kind of another clinical trial question. It had the 2 antibiotics that we were given, antibiotic A and antibiotic B. And antibiotic A had a cure probability of 60%, and it costed $50 for you to be treated with that. Antibiotic B had a cure probability of 90% and cost $80. So naturally the one that can cure you most likely costs an arm and a leg, but whatever. So plan 1 that doctors would use to treat whatever infection they need to treat with this antibiotic, they would treat with antibiotic A first, and then if that was not effective, they would treat with antibiotic B as like a backup. And then plan 2 was quite the opposite. Treat with antibiotic B first, and then if that's not effective, treat with antibiotic A. So the first question asks for the probability cured with plan 1 and the probability cured with plan 2. So with plan 1, it's to treat with A first, and if that's not effective, to treat with B. So you take the amount that is affected by A, and you take that from 100, so that's 1 minus 0.6, and you get that 0.4. So that's that 40% that is not cured by antibiotic A. And you take that 0.4 and times it by the amount of people that are cured by B. So that's that 90% that are cured by B right here. And then that is 0.36. So about 36% that are not cured by A but cured by B. And you take the 36% that would have to move on to antibiotic B, and you take that 6% that would not have to move on to antibiotic B, and you add them together and get 0.96, and that transfers to 96%, and that's basically how many people that would be treated effectively with plan 1. And you do the same exact thing to find the probability cured with plan 2. You take it's just switched around. So you take the 100% minus the 90%, so 1 minus 0.9, to get that 0.1, so that 10% that is not cured with antibiotic B, just like this. And you times the not cured by antibiotic B with the cured by antibiotic A, and you get 0.06. And then you add the ones that would have to move on to treat with A during Plan B, plus the ones that would not, and you get 0.96. And so that is 96%, and it's the exact same one as Plan 1. So, concluding, with problem 1 of the AP question will be that both of them have the same probability for being cured with Plan 1 and Plan 2. So the second question for the AP question is, what is the expected cost for Plan 1 and the expected cost for Plan 2? So for Plan 1, I just jotted here that 60% would need to pay $50 just for treatment A, and 40% that weren't treated with treatment A or antibiotic A would need to pay the full $130 for both antibiotic A and B. So here it's 0.6 times 50, so that 60% that would pay $50 is 30. That equals 30. And then 0.4 times 130, so that 40% that would have to pay $130 equals 52. And then I went over here and I added 30 plus 52 because those are the amount of dollars that you would need, and that came out to $82. I did the exact same thing for Plan 2. I said the 90% of people would have to pay $80 just to cover Plan B or treatment B, and then the 10% that weren't treated with treatment B would have to pay the full $130 for both treatment B and A. And then I did 9 times that $80, and then that equals 72. And then I did that 0.1, so that 10% times $130 equals 13. And then I said 72 plus 13 equals 85. So out of this problem, Plan 1 costs less than Plan 2. That kind of leads perfectly into our last question: what plan would I recommend? And explain why. And I would recommend Plan 1 because it has the same exact probability of working on a person, but it costs less than Plan 2. While you're only saving $3, I think $3 can buy you a soda somewhere, so it's a pretty significant amount of money. Yeah, so I would definitely recommend Plan 1. Save that $3 for your soda.